Well, hello there. As promised, a little metric system chat. For those of you who are not terribly familiar with the metric system, the thing is, it's not going away anytime soon. So we need to wrap your head around it and familiarize yourself with the metric system. The metric system, now if you are familiar with this, so it'll be pretty easy for you. These are things that you must remember for the rest of your life, your professional life, unless you get out of a field that uses the metric system. So starting up here in the upper left-hand corner, first of all, there are things that we want to measure. We might want to measure length, distance between two objects. In the US system, we have inches, feet, yards, miles, whatever. In the metric system, the meter is used. It's abbreviated by a little m. And a meter is equal to 39.37 inches. 39.37 inches is just a little longer than a yard. A yard is 36 inches. So a meter is about 3 1/3 inches farther than a yard. So if you hear the word meters and you're trying to wrap your head around it, it's okay to say, how far is 100 meters? Well, it's about 100 yards. That's close enough to start to wrap your head around. We're not, making precise measurements here. We're just trying to get you accustomed to some of these units. So if you just convert meters to yards in your mind, then you'll be close enough to get started anyway. We might want to measure the volume. Volume is a measurement of the amount of space taken up by an object. Like a basketball has a higher volume than a marble. In the metric system, we use the liter, which is abbreviated by a lowercase l, if that's what that is right there, lowercase l. A liter is roughly about the same size as a quart, because in the English system, American system, we have ounces, pounds. Oh, wait, no, for volume, we have ounces, we have cups, we have teaspoons, tablespoons, cups, pints, quarts, gallons. So a liter and a quart are almost the same. You can also think of a liter bottle of soda, or the bottle, if you're drinking bottled water, good for you. That's likely a half a liter. It'll say on there 500 milliliters, which is half a liter. We might want to measure the mass. Mass is the measurement of the amount of material present. And the metric system uses the gram, abbreviated by a lowercase g. Gram is pretty small, maybe somewhere around a teaspoon of sugar. And a kilogram, which is 1,000 grams, a kilogram is 2.2 pounds. Now, when you get into healthcare, those of you who are going to go into like nursing or something, you will be measuring the height of your patients in centimeters. I'll tell you what that is in a moment. You'll be measuring their mass in kilograms, most likely. And you'll definitely be dealing with liquids in the metric system as well. So like I've already mentioned over here with kilo, we may want to, and centimeters, we may want to make these base units larger or smaller, just like we have different units for larger or smaller in the American system, which is actually the English system, but the British use the metric system, so that's always confusing. So if we want to make the measurement between where I happen to be right now and say Southeast Campus, well, meters would be a little awkward. It would be tens of thousands of them. Kilometers is probably a little better. And how many kilometers am I away from there? So I am probably 200 kilometers away from Southeast Campus right now. So that's more, kilometers is a lot more useful. Meters, maybe we want to measure something smaller. So how are we going to do that? Well, we have a series of prefixes that we either will multiply and make the unit bigger, or divide it, make the unit smaller. So here's the make one larger, kilo. is the base unit multiplied by 1,000. So a kilogram equals 1,000 grams. Deci is divided by 10, 1/10. Like a tenth of a liter is a deciliter. Right? Grams per deciliter, measuring the material. Centi is 1/100th. So there are 100 centimeters in each meter. And each 1 inch equals 2.54 centimeters. So, not quite a third of an inch. And milli is 1/100th. So there are 1,000 millimeters in a meter. There are 1,000 milliliters in a liter. And there are 1,000 milligrams in a gram. And milli is probably the most common prefix that we'll run into. It means 1/1000th of. Now, did you know that the entire metric system is based on the properties of water? Well, so you didn't know that, did you? I can't change that. For color, for darn. All right, so if we take a cube, trying to get my pointer back, come back here. If we take a cube, that's a little bit flat for a cube, but hey, I'm no artist. A cube of size that are 1 centimeter. So look at your fingernail on your pointy finger, your index finger. From side to side, that's probably about a centimeter. Something like it anyway. Well, now you have an idea what a centimeter is. So if you take a cube that's 1 centimeter on each side, to figure the volume of a cube is width times height times depth, right? So that's 1 centimeter by 1 centimeter by 1 centimeter. Now to do this math, this arithmetic, you multiply the numbers first. 1 times 1 is what? Yeah, I know you know what that is. Times 1 is still 1. So we put the number out here. Then we still have to multiply the units. Centimeter times centimeter times centimeter is cubic centimeters. Also sometimes abbreviated cc, cubic centimeter. That unit sound familiar? Yep, medicines are often measured in cc's. And guess what? That volume is equal to 1 milliliter. And how much is the mass of the water in this cube? At standard temperature and pressure, it's 1 gram. Now I got that written down here, STP. I have to do that because, I'm a scientist. We have to be precise. So that's mostly on me, not you. Because water expands and condenses depending on its temperature. That it does. It expands when it freezes, which is why ice floats. That's a story for another day. We can measure the amount of material in a given volume. Take that basketball, and it weighs one thing. We fill it up with water, it's going to weigh a lot more. There's more mass in that same volume. That's density, the measurement of mass, grams, in a volume, milliliter. At standard temperature and pressure, this cube will contain 1 gram or 1 milliliter of water, or 1 gram of water, in 1 milliliter of space. Meaning that at standard temperature and pressure, which is standard temperature is about 74 degrees, 25 degrees Celsius, and pressure is 1 atmosphere, pressure at sea level. That at 25 degrees Celsius at sea level, in a 1 cubic centimeter cube, water in those conditions would weigh 1 gram and take up a space of 1 milliliter, and the density of water is defined as 1.0 by these physical attributes. Now let's see if I can get my pen to work here. Maybe. Well, give me a second here. Oh, that was nice. I'm still trying to get this to work. This is so much more difficult than whiteboarding class. Hey, we're not ready for that yet. All right, well, I'm not going to give me a, let me have a pen or what? Oh. All right, let's say we also might want to measure the amount of energy in a system. Temperature, what I'm talking about. We might want to measure, of course, water. That's supposed to be a B for boiling, and an F for freezing. My F is not working too good. That's an F down there. Yep, that it is. All right, so we have two ways of measuring temperature, don't we? We have degrees Celsius. Guess who's that's named in honor of? Yep, a guy named Celsius, buried at Westminster Abbey in London. I actually saw where he is interred. Go to Westminster Abbey if you get to London. It's a pretty cool place. All right, we also have Fahrenheit. He's also buried there. So which one do we use? Well, Fahrenheit is the one that's used in the United States. What's the boiling point of water in degrees Fahrenheit? That's right, you guessed it, 212. And what is the freezing point of water at standard temperature and pressure, I might add? Yep, it is 32. All right, that's pretty random. Where did he come up with that? I don't know. Maybe he had those mushrooms on his pizza that day. There's 180 degrees Fahrenheit between freezing and boiling. What's the freezing point of water on the Celsius scale? Named after Celsius, of course. That would be 0 degrees Celsius. And at what temperature does water boil in the Celsius scale? Yep, 100. 100. So, makes more sense. There's 100 degrees between Celsius, freezing and boiling in Celsius, and 180 degrees Fahrenheit in between freezing and boiling in the Fahrenheit. So they're not the same. A degree Celsius, a change in a degree Celsius represents a larger energy change than a degree Fahrenheit. It takes 180 Fahrenheit's baby steps to get from freezing to boiling. It only takes 100 larger steps in Celsius to get from freezing to boiling. Now, a lot of times people will call the Celsius scale the centigrade scale because of centi, 100, like century. And that's not wrong. Centigrade or Celsius are fine, either one of those. And so we will be measuring, and you will be measuring temperature changes and temperatures in degrees Celsius. So from now on in your professional life, you're going to run into liters, meters, and grams as the length, as the measurement of physical characteristics. We have now a rough equivalent of what a meter can be, just longer than a yard. What a liter is, just about the same size as a quart. And a kilogram, 2.2 pounds. Nice size steak there. So then we have some ways of making these units larger and smaller to serve our needs by either multiplying them to make them bigger or dividing them to make them smaller. And we understand now where the metric system comes from, the physical properties of water, all the way including the Celsius temperature scale. So we're going to run into some units along the way that are in metric system. We're going to convert some of these along the way. so that we can take ownership of the metric system. Because what do you do when you're an American and you're confronted with a measurement in the metric system? The most common response is to run away as fast as you can. But we can't do that. Remember, we do this not because it is easy, but because it is hard. And so we need to start right now, today, if you haven't already, familiarizing yourself with the metric system, and your life will be so much easier. All right, so now we'll get into chemical bonds. So, adios.